Hello everyone, and nice warm welcome from our side. My name is Blaž Mulavec, and I work as a technical consultant at Allplan Competence Center Allplan Infrastructure in Graz. And yeah, today now we will have a Allplan workshop where I would like to give you first a little bit of general overview over Allplan Bridge, because as I know some of you are already users, some of you are new with Allplan, therefore to give you a little bit of overview. And yeah, then further, hopefully we will manage everything in 2 hours, as I have quite some things which we would like to show you. As a second theme would be then we would take a look at one project where we have also road constructions with bridge. Then further, I would like to introduce you our very innovative free parametric modeling, and to show you, to give you a little bit of insight what are the capabilities and what actually means free parametric modeling. Further, I would then also like to show you about templating and how we can reuse our already used data or already checked data from our previous projects, how we can then reuse some elements or perhaps even the entire projects. And last is our new implementation in the version 24. It's the automatic parametric reinforcement, and this is really a huge innovation regarding reinforcement of bridge constructions. Yes, as it is automatic, but you will see later what exactly this means. So I will work in the version 24.01. Some examples which I will show we have already also in product, so you can open them, and if there are any questions, please just ask, and I think it's best that we discuss it. If it is a short question, we can discuss it during the presentation. If it is a little bit larger question, I would say then let's keep it for the end, and then we can discuss different topics which you might have. Yes, so to start, Allplan Bridge is actually a part of Allplan holistic solution for bridges. Therefore, it is also connected with Allplan engineering. And usually, when we start with new projects, we always start from Allplan engineering, and then we create either bridge projects, or, for example, we have different action tabs, like for road construction, where we have specific functions which are needed in road planning. And yes, so when we start bridge, usually a window pops up, and our examples which are available or delivered with the product are listed. And here you can see we have different categories of examples. We have modeling and end analysis examples, which means that Allplan Bridge is software, or is a tool where you model your bridge, and you also have a possibility to automatically derive your analytical model and also calculate and analyze it and perform, for example, also design and checks with different standards available. And we have quite some examples which, if you would like to test or to explore or to see how things could or can be done in Allplan Bridge, I think those examples are very nice reference. For the beginning, to give you a little bit of general overview, I will start actually with our getting started example, which is a pre-stressed concrete bridge. And for this example, we also have a manual, step-by-step manual, where the entire project is described really nicely step-by-step, so that if you are new or if you start, if you just started with bridge, you can actually go through all the basic functions also by yourself, and you have all the nice explanations in the manual. So this is our getting started example. It is a pre-stressed concrete bridge, hollow box bridge, with tendons, with slightly curved axis, with crossfall along the axis. And we have here also 2 abutments modeled. On the top of our user interface, you see different sections like axis action bar, then for the cross section, 3D modeling, tendons, constructions, loads, checks, calculations, options, and so on. And yeah, now, for example, all the functions are gray out, and that is with the reason because we wanted somehow to make sure that the user does not use wrong functions on wrong places. Therefore, when we start a certain definition, for example, definition of the axis, more precisely axis plan, then the functions available in this for this part will be activated. And so we can then start defining. I just need to, the example is already recalculated. Let me check this one. Also not, okay. It is recalculated, okay. Yes. And if we start with the axis, so when we model our bridges in Allplan Bridge, we have really tried to develop the software from the perspective of bridge engineers, so that the structure of the project as well as the functions are really very specific and really go with the workflow of most of bridge engineers. And therefore you can see that in the same order as we have the action bars, we have also the project structure. And of course we first always start with the axis as a base of our bridge. Then we continue with the cross-section definitions. Once we define our cross-sections, we further define our variations for our cross-sections, for example. And finally, we combine the axis with the cross-section and extrude it, so to say, along the axis, and this way we create then our structural members. As you might already know, Allplan Bridge is parametrical software, meaning that you can change any defined parameter anytime during the planning, in any phase of the planning, and you simply just press the play or recalculate button, and the entire model will be newly recalculated with the new geometry will appear with, of course, then in an analysis new results and so on. So on the left side we have our project structure. In the center we have 4 different windows. The main, of course, is the 3D model window, where we see how our model is being put together or being built. And then we have further 2 windows which open and change depending on which part of the structure we are working currently. And the third one is the analysis window. I have to recalculate the model once again because the computer was, I don't know, probably in sleep mode and did not save correctly the data or something. And yeah, and on the left side we have our property windows, where depending on where are we with our functions, the property window always open accordingly to the function or to the bridge part which we observe at the moment. And here in the bottom part you can see this is our logging window, so that when we recalculate our model, we know exactly what is being calculated, which steps are coming. For example, if something is wrong with the model, if some definitions are not correct, we also have warning and error messages implemented, so that you get a feedback directly, okay, something is wrong with the definition, with the calculation, or something similar, and that we can react then accordingly and correct our model. Of course, not everyone perhaps likes to take a look at this, because it somehow perhaps remembers you as a user on programming or something, but actually it's very clearly, if after few times you understand very easily what are these texts actually explaining to us. Okay. And further here on the left side, beside the structure, we have then the tabs for the tendon definitions, for the placements overview, and our custom trees. Custom tree serves us, for example, this is our standard default project navigation tree, and you can define also your own project structure. For example, for the precast girders, usually we would like to have our girders either sorted by the length or by the span or as desired, and this custom tree enables us that we can really structure our project as we would like to. Okay, now the model is recalculated, and as mentioned before, we always start with the axis definition. For axis definition, we have, of course, possibility to define axis manually, directly in Allplan Bridge, but usually road axis or bridge axis come from our colleagues in road planning. Therefore, we also have a possibility to actually share the axis data over BIM+. BIM+ is a kind of exchange platform where we can upload and download different project data and share it with all project involved. And yeah, by simply, for example, if we define our axis in with road tool engineering, we can then easily export it either to BIM Plus or directly to TCL. Just to mention, TCL is our project program language, and it is very practical because this is not invented by us. It's a general programming language, and this gives a user which also like to program by themselves, gives them also a possibility to make even more with Allplan Bridge models, because you can then define your own loops in a definition of, let's say, peers or something similar. And also for project sharing, for example, one project like this bridge here is only 265 kilobyte large file. It's actually nothing, and this is very practical because you don't need to send large data files to your colleagues and so on. So to come back to the axis, we have these two ways of defining axis. Not to forget our new definition now, our new implementation in the version 24, we have also possibility to import digital terrain model. And also for digital terrain model, there is the same workflow as for the axis. We can either import it to Allplan Engineering from other products which you might also use in your production pipeline workflows, or you can import, for example, survey points and then mesh the terrain model in engineering, and again export it either directly and import it directly to Bridge, or export it via BIM Plus, and then you can share it with all your colleagues, and of course you can then also import it to BIM Plus, to Allplan Bridge. And what is nice, if you work over BIM Plus connection, there is a possibility that, for example, if your colleague, your road engineer colleague, changes something on the axis, he doesn't have to call you to send you data and so on. He just uploads a new revision of his axis on the BIM Plus, and when you recalculate your project, you can then either decide if you want to update data from BIM Plus or not, and this way you have actually a possibility to always have updated data with which you are working on your project. The same goes also for the terrain model. If we then go further to our cross sections, for example, this is our main girder cross section. For this entire bridge, you can see that we have some variations in the height, then the web thickness and the bottom thickness are changing. As mentioned, also the crossfall is changing along the axis and so on. But for this entire bridge, we will define, or we need to define only one cross section. And of course, we need to know what we would like to, or which parameters of these cross sections we would like to vary it to get our end desired form of the bridge. And for this purpose, we then define, or differently, when we define our cross section, we define it with parametrical lines. And if we want to vary it, for example, some parametrical lines, some thicknesses and so on, we then simply create a variable, assign it to a specific parametrical line, and this way we then get the connection between the cross-section, the variables, and the variation tables, which we define later, for example, for the height. This is how such a table of variations looks like. We simply define our stations of the bridge along the axis, where we have some changes. For example, in this case is the height of the bridge. And we can also then define different transitions and so on. And after we connect these tables with our cross sections, we get, after recalculation, our program will variate the cross section as defined, and we have, so to say, in this one cross section, control over the entire bridge, so to say, over the superstructure of the entire bridge. In this example, you can see that we have quite some, perhaps on the first side, strange definitions inside. This is because this example is as well for the geometrical model as well as for the analysis. And what you see, actually, these lines here inside are our property sets for reinforcement. And then here we have some stress points, temperature points for linear and non-linear temperature and so on. We have here our point grids for the tendon definitions, and of course our structural units. The blue color defines the load-bearing structure, and the green color defines dead loads or structures which are only which are taken into consideration only as loads. For example, we see here some barriers, some sidewalks, and when we derive our analysis model, our program, if we define things nicely and properly, our program will automatically then recognize, okay, this is a barrier defined as a load, and we will apply it also then as a load on our analysis model. So this way we can actually have very precise models also for the analysis. If for some reason, for example, we would like to have simplified model for our analysis, this is also not a problem, because with our parameters we can anytime simplify it as desired for the analysis, for example. And talking about the analysis, we support beam theory currently in the product, but we have also very nice connections to RM Bridge from Bentley, then to Lusas, Midas, and yes, this way you can then simply just export your analysis model to Beam Plus or directly to Midas, for example. And if you export it to Beam Plus, then some other products can also have access and could also take the analysis model for the calculation purposes, for example. Yes, so these are our cross sections, and for example, to give you a brief feeling what means parametrical cross section, this means that we can then check like this if our height, for example, will or if our cross section will behave as desired when we change our heights, or when we change, for example, our this is some other line, I think this one should be our thicknesses and so on. So this is really completely parametric. And then we come to our structural members. So when we put together our cross sections and axes, we define our structural members, our girders, piers. You can see that in property windows, for example, you can see all the references of this main girder and so on. We have then stationing tables with different types of stations, then which cross sections were used on this girder, and in this case it is only one cross section, but you could use also many different cross sections. And then we see also different variants of this one and the same previously defined cross section. These tables are all editable, so that you can do changes very quickly, very easily. Then, for example, this is our variation table, where we now connect our variables from the cross sections together with our tables or formulas. It is also possible, for example, to define some variation as a mathematical expression. Perhaps for some more challenging geometries, sometimes this also is very useful. And with assigning of our variations, we then connect these parameters. And we also see here, for example, if we take a look at the height of the cross section, we see then for each station how the height is calculated and what is happening. The same goes then also for piers, for bodies, which are used for free parametric modeling. And of course, for the analysis, we also need some additional definitions to the geometry, like statical connections and rigid connections and so on. As mentioned before, then we have our parametrical tendons. And for example, if we now change the height of our cross section or the width, and if we correctly referenced our point grids for tendons, also the tendon geometry will adopt automatically with the change of height or width of the main cross section. So all parameters of the bridge are, if properly connected, of course, dependencies properly connected, are changing, adapting automatically. Then in the analysis part, we have the material definition, where we can also import materials from our library in BIM+, or we can define our own materials as well. In the cross-section area, we see then our I have lost the word. We see actually our information about the cross sections, like areas, like moment of inertia, center of gravity, and all these kinds of information, and we can check this data for each of our calculated cross section on our superstructure. The same goes also for pier, actually for all our used cross sections. Then we have of course, for the analysis, we need the tendon pre-stressing actions, and where we define how we pre-stress our tendons and so on. And of course, in the construction, under constructions, we define our construction phases of our bridge, for example. But additionally, we define also our loads, or different loads, and also, for example, superposition, evaluation, combination, tables evaluations, and design checks tasks are also in this area to be defined. And then we can, for example, also visualize our construction schedule and observe, for example, how our bridge is planned to be built. This is, okay, it's the entire construction schedule. And you can see here on one side we have our tasks, on the right side we have our Gantt diagram, and below we see our assemblies, or which parts are assigned to which tasks. Further, we have the definition of traffic loads with lane sets and load trains. Then, of course, also definitions for dynamic analysis, for earthquake analysis. For our superposition, we have a little bit different approach, perhaps as other products. We wanted somehow to give also a visual feedback how different load cases are being combined together. Therefore, we decided for this, let's call it visual scripting approach, where you have loads or load cases on one side and then different nodes where you combine them with all the factors and everything necessary. And of course, combination tables are also a must for the analysis. And at the end, our results, where we can visualize our results either as 3D diagrams or as 2D diagrams. For example, let's take a look at this one, or of course as tables for different purposes. We have different abilities, and we can then switch between our load cases, envelopes, and so on. So this would be a brief overview of Allplan Bridge. As next, I would like to show you our new implemented functionality for polygonal axis. This is a very simple example of retaining wall, and here in this example we also used the terrain model. And for example like this. So we have, in this example, we have simply imported the terrain model directly from Allplan Engineering in Collada format in this case. We have defined our main road axis, and we would like, for example, to build a retaining wall along the road axis on the side, and for this purpose we can then use a function polygonal accompanying axis, meaning that the polygonal axis in this case is reference to the main road axis, will, for example, follow the same elevation, the same profile as the main axis has it, and will also follow the curvatures. But of course, as this is polygonal axis, we then need to define how we would like to polygonize it. And for this purpose, we again define a simple table where we, on one side, define our lengths of segments. In this case, those segments are 10 meters long. And then on the other side, we define the perpendicular distance to the reference axis of our segments. And when we combine, let's do it like this, like this. And when we combine these two information, the polygonal axis, after recalculating the model, the polygonal axis is then automatically defined or drawn in our model, 3D model. And for example, we have also nice possibilities with the axis and the terrain, and in combination with the terrain, we could, for example, do, this is axis 1 is our main road axis, and for example, if we would like to calculate our distance from our axis to the terrain, we have a very nice functionality implemented in this 24 version. Perhaps some of you which are using Allplan engineering already know our CD to axis functionality, where we can calculate distances automatically between two axes. And now we have enhanced this functionality with CD to profile, so that we can now calculate distance from the axis to its own profile on the terrain, for example. And for this purpose, I just need to create additional profile, which I reference it to the terrain. I will leave it inactive, because I would still, the main profile for my axis 1 is the defined one, and I would like to keep it this way. I would only like to calculate the distance to the terrain. And for example, I will define a very simple cross-section. For this purpose, let's say, like, okay, it's okay. I will only have to reference one variable. Then I will create additional girder on our main axis. I will choose the cross section, choose the first or the beginning station and the end station. We can then choose different types of refinement, or in this case I will have station each 5 meters, like this. And for example, to get the distance to our inactive profile, we then just use our CD H2 profile. This means calculate distance height to profile. And then we call which profile we would like to use. And we will say this profile 1. Okay. Like this. We apply this function to all our stations, recalculate the model, and you can see very nicely, for example, that our cross-section has automatically adapted to the profile of the terrain. And this is very practical function for different kinds of wall constructions in the infrastructure, or for noise barriers, or retaining walls, or perhaps in the hydrotechnics, some dam constructions or something. I could also imagine that could be easily done this way.
Can I ask you
Of course, yeah.
Can you do the stepping? So the height is like steps.
Like steps.
Yeah. Depends on the axis stations. Usually you build it like stepping.
We could probably do it. We would for this purpose, I imagine that we would have to use some mathematical expression as a variation, and we would then simply, we would then simply apply this variation. For example, we would create such wall and apply an additional variation to this wall, which would then make the steps out of it.
The stations.
Pardon?
So, yeah.
Along all the stations, yeah. And also for some things which are for which we perhaps don't have the functionalities, we have possibilities, you also have possibility to use Python parts. These are so-called Python scripts where you can program or define, or you can do whatever you wish with these Python parts, so to say, and you can then place these Python parts in our cross sections, and then these different codes do their work, for example, for some even more complicated things. One such example was, for example, noise barriers for Deutsche Bahn. We have developed a Python part which has the concrete foundation wall of the noise barrier. We have all the noise barrier parts, upper parts, with the steel parts with the piles below and so on. And for example, their demand is, because in the railway constructions they are always referencing to the rails, and they have some certain standards. I don't know, it can be just 50 centimeters above the terrain, it has to be the concrete, the rest is then this protection material, and below we have to have so much concrete, and piles have to have this length and so on. And we have simply generated such Python part, and then when you create your axis, when you create your axis which you need for your walls, you simply apply this Python part, and this Python part places the wall protection parts automatically along the axis. Generally, perhaps to mention, to better understand our philosophy, our senior team in Graz has a lot of experience in developing software solutions for bridge constructions, and this gave us a possibility that we, with this deep insight of workflows, of functionalities, and with new innovations or new technologies which are coming in the digital world, we have a possibility to, or our wish is to optimize and to automate all kinds of processes which are repeatable, which are possible to be optimized, and to this way save you your working time, planning time, to give you how should I say, more precise data. If you can reuse your data, which you have already double-checked, where the project is already built and you are sure that this data is okay, why simply not reusing this data? Why inputting it again and again and losing time? And our philosophy is simply, we are trying to find parts of the workflows which are possible to be simplified and optimized without losing anything on precision or on the control, your control over your model. So this is our general approach regarding the development of the software. Yes, so to come back a little bit to our retaining wall. This retaining wall was again defined very simply. It's a simple cross section which is then extruded along the axis as a girder 1. And for example, these anchors, with the version 24, you have much better functionality already in Allplan engineering, specialized for anchors modeling. But we wanted to show also our new functionalities of bodies and free parametric modeling, like body groups and containers. And for example, for these anchors, I have defined one anchor, which is of course parametrical. I can change it for my next project as I would like to. And this is a simple body group of prisms. And then I have used containers, which are so-called bodiless templates, which have their local coordinate system. And then in this local coordinate system, this virtual place, as you can see, there is no wall around. This is like template space. We can place different structures. It could be piers, it could be piles, it could be walls, whatever, which have some certain relationship, either local or global, between each other. And for example, we want to have it always in the same set. And I have used this philosophy to place the anchors in their position. And then I have just simply took this one container with one set of anchors and place it 1, 2, 3, 4, 5, 6, 7, 8 times. And this way we have modeled our anchors. Further, out of our axis-based modeled retaining wall, we have a possibility to create so-called extraction body, which becomes a body which we can use for free parametric modeling. But this body always stays completely connected to our girder, to our axis-based design girder, meaning that if we change our axis, for example, somehow, let's say here, for example, I would like to change, okay, this is probably in the other direction, this, for example, if we recalculate our model, we have changed our axis and all the things adopt automatically because they are all linked together, and this way all the things adopt to a new situation very quickly. I can, for example, are here many who are still working in 2D environment? Perhaps some of you? No? Okay. We are very happy to hear that, everybody. Okay. Yes, so this would be our small example for free parametric modeling and for axis. Then let's go further to our global variables. This is an example for templating, or how we can reuse our already existing data for new projects. And if we know, for example, we have some certain types of bridges which are our everyday work, which we produce, I don't know, 10 bridges per month or per year, for example, we can then prepare such projects with few additional definitions, and to make it so-called as a template with global variables. What this means is following. In Allplan Bridge, we have possibility to export all our data partially as well, meaning that everything what you see here in the project navigation tree, like axis, structure, materials, different kind of things, project settings, combination tables, whatever we have defined in our project, we can export partially, and this gives us then one so-called master TCL file, where all the sources are linked. I will use it like this. And then we have one folder with all our elements which we have exported. And this way we can then quickly say, okay, I need materials or project settings, for example, standards, whatever. From this project, I just simply add it to my new project, and this way I save time and errors when re-entering data. We would like to avoid re-entering data. And for example, additionally, we have then here defined so-called global variables. In this case, we said we would like to vary the bridge length and the width. And of course, this form now has no piers, but if we make it longer, we would like to have some piers placed automatically. And we can also, then we have global variables for the pier height and so on. And out of this model now, for example, if I change the length to 45 meters, for example, I just save my file, import it in Bridge, and I already have a different bridge with 2 piers, and I could go then further and say, for example, let's do it like this. I want to have it also a little bit wider. I could also change the height of the pier. Again, save my TCL file, re-import the project, and I already have completely different, I mean, similar but different bridge. And this, for example, to prepare one project in this manner, if you know the workflow, it should take you perhaps few hours maximum, and then you have your entire project, not only some cross-section or some part of the project, you have your entire project as template which you can reuse. And for example, we could then also further say like, okay, let's make it completely different again. Let's say 30 or 25, I would say 8 meters. Save again, re-import my project, and then it's again completely something differently. So there are a lot of possibilities how you can reuse efficiently your data, your old projects. As next, I would like to show you also our new implementation or enhancement of 3D freeform 3D modeling. But first, I would like to give you a little bit of impression how 3D free parametric modeling looks like in Bridge. And for this purpose, I will model 2 abutments with 1 bridge, and then we will make here one so-called trousers road connection, or where the way splits. And for this purpose, I have defined my axis. I have my main axis, my main bridge axis, and the other one is so-called accompanying axis, meaning that it is referenced to our main axis. Then I have prepared a simple cross-section for our abutment wall, for the abutment foundation, also piles. This will be the very simple cross-section to represent our bridge. this is our abutment wing cross-section, and yeah, some other simple cross-section, which I will probably not use now. And yes, so I would first like to model abutment. As we have, for example, two same abutments, I will make one template, which I will call abutment, yeah, abutment. The cross section is correct. And we are now again in this virtual template space. Let's say we want to have 10 meters long abutment wall. And here, these sliders, which you see, these small arrows, are actually variables which we have defined in our cross section. This way, program now knows, okay, these lines will probably change in some directions, and therefore when we create 3D body, these lines become, so to say, then the areas which we can then move and slide and change the dimensions of this wall, for example. So we have wall as next. I would like to have all in one template, so I will make a group of templates. For this, I will simply create a new prism template inside of this template, and I will call this one foundation. We have different possibilities. We can either union with Boolean operations already here in this step, automatically our different prisms, or we can distinct them as well. And this is where we would like to reference it. And now I will change my cross section, and I would like to define it from one docking point to another. So between these two docking points, for example, this is our foundation wall, foundation part, and we say, okay, we would like to have some overlap here, some extension on both sides, and for this we will simply just click on our prism, choose the function move slider, and we will say, okay, let's say 1 meter additional in this direction and 1 additional meter in the other direction. And then, of course, our abutment needs wings as well. So we will say wing left. Choose again the appropriate cross section. Then I will say, in this case, we will reference it on the docking point, and we will define the thickness of 0.6 meters, let's say. And since the other wing is the same, I can also copy it. We can decide if we want to copy transformations like rotations or change dimensions or whatever, or not. And yes, this is the one. Okay. Okay. And now I will only move it from here to the other side. And for this purpose, I will snap this point, reference it here. Now we need also, we would like to have some material, for example, which we choose from our okay. this is our abutment. I see now here that we should also adapt, for example, this width here. We will simply move the slider and we will snap it, for example, to this point. So now it sits nicely. And with this, our template is ready. And now we simply need to drag and drop it into our 3D space. And we say abutment 1. Then we choose our axis and the geometrical position 1, which we would like to use. For this, I will use relative distance, and the geometrical position 2 will be from the template, because I would like to place it only with one reference point. We could also place it with 2 reference points, for example, on a bridge cross-section, and this would gives us advantage then that when the width of the bridge changes, the width of the abutment would change automatically as well. So axis 1, at the beginning, we will have 0 height. And now I will also change, okay, I will change the reference of origin and we'll put it to this point. Just a second. So, yes. Okay. Okay, and we will also need to rotate it. We select the rotation axis. This is the one, yes. And we will rotate it 90 degrees. And this way we have already referenced our abutment to our road axis. And now we do the same also on the other side. Select the axis, then the station, the height above or below the axis, and we will apply. We will use it from the template. I think also here I need to change, yes, I need to change the reference to this point, and I will also rotate this one, so rotate it here, this, again minus 90 degrees, and we have already prepared our 2 abutments. And now we need to define our superstructure. For this we will use axis-based design approach. We will take our cross-section, our first axis, then first station, last station, let's say 1 meter refinement, or stations each meter. And this is already our first girder, and the second one. Will be referenced to the accompanying axis, also from the beginning to the end. 1 meter refinement. And now, for example, up until version 24, it was not possible to union such two girders with Boolean operators. Now in the version 24, we can simply define extraction bodies from these girders. We will take the entire girder as an extraction body, and also the second one. Yes. Now we have two bodies, and we will use union function, select the first body, secondary body. And now, if we hide our girder, and the second one, now we see this is our so-called united body from these two girders. And a nice thing about this is that also these bodies stay further parametrically connected. For example, let's change it in the other direction, perhaps like this. And when we recalculate our model, we have still everything connected, dependent between each other, and yeah, we can, this way we can do, as mentioned before, any change at any phase, in any phase of the project, and we don't have to we don't lose any work which we did before, and we can simply continue with our project.
Quick question.
Yes?
Can you do the cross-section or 3D representation now with these two connected parts? So you select one station and do a 2D representation.
Yeah, of course,
it's
of
like
course.
One body.
Yes. For example, we don't have detailing functionalities in Allplan Bridge because for this purpose we have Allplan engineering. Yeah, I forgot to mention at the beginning, Allplan Bridge is really software specialized for bridge design, and Allplan engineering is so-called tool for detailing, for reinforcement, for plans production, and so on. And if we would like to for example, to create now different sections for the plans and so on, we would simply export the model to Allplan engineering, and then we can create sections, plans, reinforcement, and so on out of this model here, coming from Bridge. And if we, for example, after we have created sections and we notice, oh, we still need some changes done in Bridge, you can still go back to Bridge, make the change. You then just simply need to update update your project in Allplan engineering, and with update you don't lose your work in engineering, and when the new model comes, all the sections will be also automatically adapted.
Which are already in the paper?
Yes.
Layouts?
Yes. This can be all automatically adapted.
So you create the layouts, you create the
exactly.
sections,
yes, of course, you have to.
You have everything dimensioned.
Yes.
When you do the change, you import it.
Yeah. But if your bridge went to the left side instead of right, you may end up
you
without
have to lay out
paper space. But
you don't lose your work. You don't have to again cut the stuff and so on. Yeah.
I have another question.
Yes, please.
Sorry. Is this superstructure now sloped in cross direction? Because when you have the slope, usually you have the slope. And now you connect the abutment. Yeah. So the one part of the abutment is lower than the other, and this is usually a big problem with modeling. So how you solve this?
you could do it, for example, in different ways. I would do it probably, yes, I would do it again with free parametric modeling, but for such abutment I wouldn't take the cross section from the side as I did now. I would take it from the front and would create the prism body simply in the other direction. And to get the exact inclination from the superstructure, I would, for example, copy this cross section. I would copy it so that I have really exactly the same lines. I would remove the structural unit because I don't need it for my abutment, and then I would design my abutment wall around this. For example, I would simply define my cross section like, for example, like this, or around, and then I have the exact form, or I can follow the exact form of the bridge. And to create the abutment, I would then create the prism in this longitudinal direction, and then the wings and everything can happen in the same principle as I did it now, and this way you could. And this, for example, if the if the inclination is usually defined by a line by angle, meaning that, for example, if later you say, oh, we don't have 2.5, we have 2.7%, you just simply change the, for example, I will quickly just define one line like this, and you later just change your, I don't know, to 25. Oh, okay, this is a little bit like this, for example, and recalculate the model, and the new situation is also adapted.
So, what about the longitudinal slope, which this superstructure goes? So, when you create this cross section of for abutment, you extend it in this direction, like in longitudinal direction.
Along the straight axis.
It's like horizontal.
Yes.
So, yes. But if you have this room for pre-stressing and so on, you have a long console wall or plate, which should follow that. So, what is the solution?
We have also, for example, functionalities, slice functionality, for example, where we could what would I slice? Okay, I will simply choose, for example, let's say these 3 points, and I don't want to have, for example, this upper part, and this way I can cut it in any direction I would like. So yeah, you can, I mean, every or almost every complicated geometry can be, how should I say, taken apart and built again, rebuilt with simple prisms, simple prism bodies. And of course, as we are used from our engineering work, we always have to think a little bit about our structures. No program will do it everything, especially not thinking. So we have to think what we would like to have at the end, and then we decide how we can model, from which side we would model it, how, or will we cut it, or will we define some inclinations in the cross section and so on. But almost every geometry can be built with prisms. For example, our project manager modeled the digital camera with prisms in Bridge, for example. Or I tried some architecture also, some prefabricated elements for low-cost housing, I have also modeled it in Bridge with free parametric modeling, for example. So, yeah, a lot can be done. Of course, this is our second version now, second implementation or first enhancement of the first implementation, and with every version we enhance our functionalities, especially on the basis of the feedback from the praxis. We are very often in contact with you, so to say, and if you talk to us where you have difficulties when using Bridge or Allplan and so on, we can then, for the next, or for example for the next two versions, we can then find some solution and implement it, so that which we also do regularly. For almost for every new version, we have some specialties which come out of the praxis and which we implement as a priority. So if there something would not be possible to model, we would do our best to help you either find the correct workflow or some other workaround, or perhaps an implementation or an enhancement of the functionality in the coming years. Close cooperation with our customers is very important for us, because yeah, after all, we do not develop these tools for ourselves and to satisfy our imagination, but we are winners if you are winners, if you do your projects with high quality, with nice profits, so that you can work normally, and if you are winners, then we are also the winners. This is our philosophy. Okay, and now let's take a look at my favorite topic, and this is the automatic reinforcement. You probably all know that reinforcement work in planning is very time demanding. If the changes come, a lot of work goes lost and things need to be repeated. And yeah, now we have found a solution in Allplan for which we can say with very high certainty that no other product has it now. And this is a two-way link, meaning from we can send data from Allplan Bridge to Allplan Engineering, where we reinforce our bridge models, and because if we have analysis possibility in Bridge as well, for example, if drafter decides, okay, there are some different quantities of the reinforcement in my engineering model, he can then send this data also back to Allplan Bridge, where Bridge engineer can again do the analysis and check if these new quantities, for example, satisfy all the design checks and so on. So this is a very, very nice functionality. And yes, I would like to show you how this works. So again, I have, for this example now, I have taken the cross-section, this hollow box cross-section, and I have defined different so-called property sets. So I have two layers of longitudinal bottom reinforcement, then I have two layers of the top longitudinal reinforcement, and shear in the bottom, in the top, and in both webs. And these property sets look, for example, look like this. I have defined this red line, which you can see is actually a line which is kind of a guiding line along which the longitudinal rebars will be placed. Then for the second layer, I did it on the inner side. Then for the top, I have one which goes through the entire cross sections on the top, and one which goes only half half of the cross section, because later when we will take a look at this reinforcement in Allplan engineering, to have a little bit better overview, I have decided to define it like this. Of course, I could reinforce the entire cross section naturally, but then we would not, it would be difficult to distinguish what we are actually looking at. So this is for the longitudinal reinforcement. We simply define the the property set. We define the so-called boundary line. Then, of course, the material, bar diameter. For the analysis purposes, we can check the option if we want to use it for shear and torsion as well. And if we calculate the analysis in bridge, then the program will deliver you with the values of required reinforcement areas. In this case, I did not make, for this small example, I did not define the loads, so there is no analysis part. But this still doesn't mean that we cannot use the reinforcement functionality. In this case, we simply then just define our values in property windows, which we received, for example, from our colleague which did the analysis. We can also, along the axis, we can also have different quantities of reinforcement, and usually this way we optimize the reinforcement layout. So this can be defined in variation tables and then simply assigned to our defined reinforcement area. And then there are some further definitions, like the position from the first bar. For example, on this line, we can position the first bar at the first point of this line, or we can have some offsets, also some offsets from the edge. For some cross sections, or let's say most of cross sections which don't have some special complicated geometry, we can also use the automatic geometry definition, and then we simply define the cover, concrete cover. And if we want to use to place these reinforcement bars automatically, then we simply just check the option Allplan Python part for reinforcement. We choose from our Allplan library the Python part which we assign, and then simply save. For the shear reinforcement, for example, like this, for the shear reinforcement, we have to define the form of the stirrup, or let's say the basic form of the stirrup we have to define, but all the hooks, the overlaps, the radiuses in the corners and everything, this can be then defined via parameters in Allplan engineering. So you don't have to really define every detail of your stirrup, just the basic form where it should lay. And yes, once we have defined these property sets, we then simply go to Allplan engineering and import our model. And yes, I forgot to mention, for example, you see here now also bearings and street lamps at the top. Also, these are our Python parts, which I have placed in the cross section. I will show you later. And we use Python parts also for such equipment, or for, we could also use it for example, for steel struts at the side of our cross section. Actually, for every element which is repeating itself punctually along the axis on some specific stations, for example. And yeah, while we drink coffee, we don't need to bother a lot with reinforcement, and the reinforcement is placed automatically. You can see the stirrups, you can see the longitudinal reinforcements, and for example, bearings and street lamps here. If I show it in the animation, a bit better perhaps. As mentioned, are also Python parts, which can be also visualized in Allplan Bridge. And we place these parts simply with the function Python part placement, where we start the function, for example, and we choose some intersection point, for example, where we would like to place our part. We can then also orient it with the second point, or we can simply just confirm it, then it will be always globally in the vertical direction. Further, we have to choose which Python part we would like to use. In our libraries, we have cuboid and cylindric bearings, we have some bridge struts. We have also reinforcement for a precast eye girder, we have pile reinforcements, and we have street lamp. And for example, if we choose street lamp, then you see all the parameters which can be, if we check these parameters will be imported, so to say, with the part into our model, and then we can change the height of the lamp or the dimensions of the bearing and so on. And after confirming, recalculating the model, I will now delete this one. We can then see in our 3D model our Python parts. And for example, and up until now it was so that if you have, for example, defined the bridge in Allplan Bridge, then imported your model to Allplan Engineering, and then you have defined your reinforcement. Of course, if you have then, after you have already defined your reinforcement, if you have then, so, okay, we still need to change the web thickness, for example, you have then changed the thickness in bridge, updated your model, but it was very difficult to use already defined reinforcement on this new situation of the model, so you had to make a lot of corrections of this reinforcement. And now with the automatic reinforcement, for example, we have now just a simple straight pier with straight bottom and continuous crossfall, and web thickness is also always the same. And for example, I will now I have defined some variation tables for the change of the height. So I would like to assign this, and we will say, for example, for the height we will use h. and after assigning the variable, you can see, after recalculating the model, that we have changed the height of the cross-section. We will then further, we will make also web thickness variable. So above the pier, it will be a little bit exaggerated, 0.7 meters thick. So let us assign also this variable, web. Again, SM. So now, if we take this projection like this, you can see that the web thickness has changed. Then we can also bottom thickness. So now we see that our geometry has quite some changes, and if we update our model again in Allplan Engineering, we see that the reinforcement changes also accordingly with the change of the geometry. So practically we have not lost any work done before the change, and of course we can, with this new workflow, we can allow changes also anytime later. For example, also at the end of the project, it could be that we might change some things. I will also change the pier width.
We didn't lose any work because we didn't do any work. Everything was done by the software.
Yes. So we change also the pier geometry, and we can see that also the pier reinforcement has changed accordingly. I'm personally a big fan of this function because I never liked reinforcement works on projects, and I found it always very, time demanding and actually not interesting, so interesting or attractive work. And this new functionality makes me very happy because, now we can, as engineers, we can really focus more on tasks which are in bridge engineering important for bridges and for our work, and we don't have to lose time anymore on such repetitive tasks. For example, what I have mentioned before, we have further, also in engineering, we have further still control over our Python parts which we have placed. We can change, for example, bar diameter either in engineering or in bridge. It depends on your workflows. For example, some larger companies, their production pipelines are usually divided in the departments, so that one engineer does, I don't know, geometry modeling, next engineer does analysis, a third engineer does then detailing and plans production and so on. And this gives us the flexibility that each of involved in the project can do the change of the reinforcement, and the data is still connected meaning that if we make a change here now in bridge, for example, here when editing regions, we see different lines. And if we would have also the analytical calculation from bridge, we would have then one line representing the necessary reinforcement, which comes out of the calculation. Then we would have our blue line representing the drafters reinforcement areas, and so on. And with these sliders, so to say, we can then very easily control the reinforcement areas and also the regions. I would just choose another. I think this was the other Python part. No, these were the stirrups. Yes. For example, here, if you remember the reinforcement table, variation table from the bridge, you can see that this table with the reinforcement areas has been taken over by the engineering, and now we can still control these reinforcement sets. And for example, for some reason, either we increase, decrease the reinforcement areas, we save this, and then when we come back, and here transfer values from Allplan engineering. For example, these are the values which I have from my variation table, and these are the new values which I have changed from the engineering, and this way I can then very easily transfer the data also back to Allplan Bridge, and I could, for example, now do the check calculation analysis and to prove that this, for example, these reinforcement sets are also satisfying all the design checks. Yes.
Question?
Yeah.
For example, can you implement now, this is automatically, and it is one roof of reinforcement, which follows the curve of the bottom part of the bridge. So, can you do the second layer only some segment above the bridge, and how these influence the necessary reinforcement that you show us in table? You know, it's the amount of reinforcement. It goes from one layer of reinforcement, or if you do the second layer manually, this is updated?
No, it is each property set has its own reinforcement areas. And I have defined the table only for the bottom one layer, and therefore these areas which I have changed, these areas are also only for the bottom one layer, so that you can control each layer separately, and you don't, this way you don't mix the areas between the layers, because I think, or we think that this could cause quite some confusion if we would mix, for example, two bottom layers with the values and so on. And therefore we have decided, okay, we let the user decide where or how many layers at all should be placed, where they should be, and then the user should also control each layer, could control each layer separately. That is the main idea. Of course, this is our first implementation of this new technology in Allplan, and as mentioned before, with every further version, also this different functionalities will be enhanced. For example, if the praxis shows that for some reason we would need to control, let's say, all bottom layers, we would like to control bottom layers with one slider, for example, like this, then of course we will adopt this. We will adopt this also in the functionality, and we'll make changes of the functionality accordingly, so that it can really serve you in the field in best possible way.
What about the overlapping?
Yes. When we open one property set, for example, we have here general settings like bending pin factor. That's what I have mentioned before about the radiuses of stirrups and so on. We can change the cover, and there are also some further settings or functionalities which are actually overtaken from the normal reinforcement functionalities in Allplan engineering, so that also with this automatic reinforcement function you get all the, how should I say, the statics or the fine-tuning possibilities of standard reinforcement functions as well. So you can choose, for example, you can choose the shape type, the shape delivery type. You can choose the bar start length, overlapping lengths. Then also how you would like for your overlapping to happen, all in one line, or like a little bit offsetted overlappings and so on. So all these things can be defined in Allplan engineering. And as mentioned, if the need from the praxis would show that some additional things are necessary or are missing for this functionality, we would then enhance it in the coming versions. And yeah.
Can you also modify, if you want, some bar individual?
Yes. You have, for example, this reinforcement has the same properties as standard Allplan engineering reinforcement. The only difference is that it is placed automatically, and you can now do whatever you are used to do in Allplan engineering with your reinforcement. It has no restrictions. Although it is Python part, it has no restrictions, because Python part is actually this function which places the bars, but the bars itself are Allplan engineering reinforcement bars. And for example, I could show you also what I have mentioned before. For example, let's do some section. Let's do some simple section. And let's choose it from, let's say, here. Let's take this. So we have here the section of this situation now, and if I go back to bridge, for example, and I could say, for example, I will add here, let's say, plus 0.10 centimeters on all the values, and we will also change the height a little bit more as well. So plus, let's say, 0.2 meters. And we have to recalculate the model. That's a must. Without this, there will be no change. And if we now again update our model, you will see that the reinforcement will adapt, and also the sections will change automatically with it. So you really, what we have discussed at the beginning, you really don't lose your work if you have already done your plans, if you have already prepared your layouts and there was some small change, you don't lose your work. So all these things go automatically. And yes, so with this I would near my end, and if you have any questions to anything what we have seen today or also anything else, please, you are welcome to ask. Please use the chance. Or if you have later on, when you will be driving home, perhaps some questions will arise, you are always welcome to contact us at our support, for example, and we will be happy to answer you any kind of questions. If you contact our support, it doesn't mean that we will answer you only questions regarding your product. For example, if you ask us what would be best workflow with Allplan in combination with my tools which are already used, for example, now, is there any chance to optimize my workflow, my production workflows? We will be very happy to consult you, to give you advices, to find together with you and with your team the best solution which fits you and your project. So that, as I mentioned before, that at the end of the day you will be the winners and we also together.
Question?
Yeah.
When you create the layout, the reinforcement, and mark everything like you want it, so you have a small change. I noticed that programs works when you update. What this means? It updates all the drawing, because if you have a bridge, you have probably 60 drawings, or maybe it has more. It's a lot of drawings and really time-consuming, and it means that it will update all the reinforcement, or it will update only this pair. And also, what happened with the marks, that you already replace it like you want it, so that the drawing is like nice picture.
Yeah.
So what happens?
Yes. So when you update your model in Allplan Engineering, for example, if I use this function, I can show you here. We have a link between engineering and bridge, and this link is working only on your command. So there will be no automatic update, or nothing will happen without your control. When you press update or import, then the Allplan Engineering software goes simply through all the, for example, through all the drawing files which you have, and checks all the data simply if there is any change or not. If there is a change, this change will be then calculated and placed in the model. If not, then the program goes simply further. And the same goes then for I don't know, for dimensioning lines and bar marks and so on. If there is a change, of course, then the change will be done. If there is no change, then these marks or dimension line will stay as it is. But of course, the program has to check the entire bridge or the entire structure, because otherwise it cannot know where is the change, or where the change will happen, or where the change has to be implemented, or updated in the model, in the 3D model. So, yeah, you do not lose your layouting. Of course, let's say, for example, if I change now here the width of the upper bridge part, I don't know, for 2 meters, and you have already placed your sections on your A3 or A1 paper, and of course then something will have to be moved probably, but you won't have to do again dimensioning, you won't have to do again labeling and so on.
Question.
Mm-hmm.
What type of superstructure can we model for bridges? All the time? Means composite with simple girders and...
Yes. Regarding just the modeling part, you can actually model everything: steel bridges, concrete bridges, composite bridges. It is no problem at all. For the analysis part, we are on the market just a few years now, and of course development takes also a lot of time. So for the analysis part, we do not support, for example, design checks for steel structures. We did not implement it yet. We have design checks for concrete steel, for reinforced concrete bridges. For example, for precast girder bridges, we have special functionality, so-called link girders, where you can then very easily define a template of your, I can also show you a nice example, where you simply define your template of your girder, and then on your piers, on your abutments, you need to define your reference points, or bearings, so to say, and then you simply just place, with few clicks, you just simply place your girders into the model. For example, here you can see such bridge. I will turn off the terrain so we can have a better look. And for such precast girder bridge, we have, for example, this is a girder cross section with points for the tendons, and this boundary here is actually will be used for haunch modeling. This is also one very nice specialty of Allplan Bridge. Why? Because, for example, this is our concrete deck. It's a very simple straight deck, and then we have our girders below. And for example, if the deck is following the road axis, our precast girders are usually straight. So therefore we have a very complicated geometry between the deck and our girder. And also for this we have found a very innovative solution. It is called haunch. And you simply defined approximately a boundary which has to be enough high that it somehow comes into the deck, and then you just need to use the haunch function, and the program will automatically fill this space between the deck and the girder. Here you can see, for example, this part here. This blue part below the deck is, for example, the haunch, which is automatically calculated, and you can see that it is changing along the axis because the road axis has different alignment as our precast girders. And yeah, this is also very practical workflow to quickly define your precast bridges. And we
calculate that bridge?
Yes, in the version 24 we have implemented also composite. The only thing which is missing in this implementation now is the crack concrete above the piers. For this we have now some workaround, but of course with the next version we will also implement this missing functionality. And bridges also, I would like to show this one. Bridges also need to be represented nicely, so we have also nice connection to twin motion as well as to Lumion, where you can then also visualize or make nice renderings or videos of your road constructions or bridges, or perhaps even the entire construction process can be visualized, because we have now in engineering also the construction action tab, where you have your cranes, your equipment, construction site equipment and so on. And yeah, a lot of things can be very nicely rendered or presented for our clients, infrastructure clients.
You have these movies from Spanish guy that has this weird
no, I do not have it. Željka, do you know, is Javier also on YouTube? Okay. And this is, so to say, live connection, so that you can work in parallel on your model in engineering and in twin motion. And as you could see, you just need to update your model then in twin motion. Find some textures, give it a little bit of life. And this is, for example, also one type of precast girders, girder bridge, more typical for Asia, for example. They have a little bit different principle for precast bridges as we do in Europe. Let me see. Okay, great. Okay. Yeah, this is this is our colleague from Spain, and okay. Some time. Okay. Patience. Look at this. It's quite large, I assume, therefore it needs some time. Yeah, this visualization was done by our colleague Javier from Spain, and he's also a very passionate bridge engineer, and he did this model himself as well with Allplan Bridge. So yeah, there is a lot possible. We don't claim that everything is possible with bridge. As mentioned, we're a young product, we are aware that some things might be missing, especially in the analysis, but for the modeling purposes, for geometry, we were very confident that with our tools, we are sure that you could design your bridges in much better, quicker, and probably also nicer bridges could happen then if we have more time to think freely about them. So,
thank you.
If there are no further questions, thank you for your...
I have one.
Yeah? Welcome, welcome. Just please.
We were discussing about bridges, but we didn't mention tendons, first.
Yeah.
So I'm wondering, of course you can model tendons, but in the end we need to create a drawing, and this is really time demanding. We should have some, do you have some simple solution how this is automatically positioned longitudinal section of the tendons,
yes.
level of the, each station level,
yes.
and so on.
Yes.
It's possible. And
yes. So, for example, the so-called developed plan view and developed elevation view overview in Allplan Bridge. Elevation view overview in Allplan Bridge. Then for tendons, you could create a report where you have all these data or all these constraints which you have in the table when defining the tendons can be listed together with your plan and elevation developed view, with your pre-stressing diagrams. And we can also define tendon report. I think if I don't define this any special point grid, then it should be defined for all. Not okay. Then I will simply say we have to check the name of the grid. So let's say this one, point grid 1. And we can create reports. This and let's see now. What's the name?
Say about drawings, because you asked
About the drawings.
all these tables that you want to have for the position and the height for the construction site. This is what we also started with the user using visual scripting, so it should be available soon. Very easy solution, but each user has different tables. So if you are interested, we can also do something for you. So it depends on what you have and which kind of output.
usually it's good if general is okay.
Да. Yeah, we in Allplan we have also this functionality section along curve, and for example, this way you could then get your developed view or developed plan in Allplan engineering, so you have the exact position of your tendons. And beside that, we also can generate reports in Allplan Bridge. What did I define wrong? Tendon 1 and vision. Let's see. Forces, geometry, yes, for example, and this way you can also export the exact coordinates for each station, or actually I have here defined the refinement of each 20 centimeters. You can have it, I don't know.
Of course, you can choose it.
You can choose,
okay.
And this way you get your coordinates for the tendon layout at each point. So you have plans, you have coordinates, and this way you would have all the required data to get your tendons not only modeled but also placed on the construction site.
And these tables, this data, this is in Excel sheet.
Yeah, this is
but
exported.
This table is also in the Allplan or Allplan inside, so that it is live. Or you need to always export.
No, this is
and
not.
And put it back to the drawing like.
Yes, this is. I think this one. Was it here?
If you want the Excel data to be represented in Allplan, you can import it as an external reference. So every time Excel changes, the report is also changed, but it's not connected to
it's not like
the drawing.
It's not inside the Allplan, this table. It's always
No.
goes to
Yeah. This is a separate Excel file, but now in the version 24 we have also a very good reporting tool. We have noticed that almost every engineer does his reports in Microsoft Word, and we said, okay, we won't invent hot water again. We will simply take Microsoft Word and we'll develop special functionalities which an engineer needs for his reports, and this way we can then make a live connection with Word document where you have your databases, in Word databases of your exported pictures, tables, diagrams, whatever you export from Allplan Bridge. And for example, these reports can then are live connected and can then be automatically updated after recalculation. For example, if the model is recalculated, you get a notification in Word saying that there has a change happened. Do you want to update your report with new results, with new tables, with new pictures, for example? And you can always choose which results you would like to put into your reports, for example. So with this workflow, you could get, for example, also then such table to be live directly connected with Bridge, so that it could be probably updated with each calculation. And talking about reports, for example, we can export our 2D diagrams, design checks, for example. This is, I don't know, this is fatigue, I think, yes. And you can see this is also Word snippet. And here you have, for example, all different kinds of reports for analysis, calculation. For example, this is fatigue check. Then we have reinforcement design. We can see exactly our areas and so on. And also, if some checks are not satisfied, you will get a message which check was not satisfied and what exactly happened and so on, so that you can react accordingly and make the corrections in your model. So, if no further questions, I want to thank you again for your patience, and we are very happy to see you in such a large number today here. So, and welcome to test, to use, or to simply call us and ask us whatever you are interested in. We are happy here to help. And yeah, thank you once again, and